About the salts. Salts, you know very well, when acids react with bases, they form salts. Okay, you know that acids when react with bases, they form salt in water. And we have studied about the type of salt, that is acidic salt, basic salts. When strong acid react with weak base, strong acid react with weak base, it will gives you acidic salt. Acidic salt. Okay, we have studied this one. And when strong acid react with strong base, it will give you neutral salt. So that we have studied. Now, what we are going to study here is today that the types, the salt that is in our syllabus. The first one is NaOH. NaOH is not a salt, it is a base. But since its preparation is done by common salt, that is NaCl, it is prepared by NaCl. So we study this one in salts. Okay. So NaOH, that is caustic soda. Caustic soda, that is in our syllabus. Next one is bleaching powder, that is calcium oxychloride, that is bleaching powder. Bleaching powder. The baking soda, NaHCO3, that is baking soda. Only three today in today's class we are going to discuss this one, and the problems related to this one. Okay, the rest two is, if we got the time, we will study this one, plaster of Paris, that is calcium sulfate, hemihydrate, is plaster of Paris, and the next one is washing soda, Na2CO3 dot 10H2. Okay, that is washing soda. Okay, so let's study each and every one by one. Okay, so we will jump to this one first. That is baking soda. So baking soda we're going to prepare and study each and everything about it. Okay. So it's my request that every student must turn on his or her camera. It will be much comfortable for me to study with eye contact. Okay. So let's study, dear students. This is very important, and this is very, very important for the examination point of view. Okay. And we're going to discuss each and everything in detail. So today we're going to study, that is baking soda, and baking soda is sodium hydrogen carbonate. Okay, how it is prepared? It is prepared when we have NaCl, the common salt, NaCl. When it is mixed with water, it forms brine. The mixture of NaCl and water is called brine. Okay, and when ammonia gas is passed through it, it forms ammonical brine. What it forms? It forms ammonical brine. So it is, let me remove this one because so the three things together, these three things together are called ammonical brine. Ammonical brine. And the last thing is carbon dioxide that we pass through it. And these four things are mixed up together. They form sodium hydrogen carbonate, that is formed soluble, or a precipitate is formed. Means what is precipitate? The formation of some insoluble substance that does not dissolve is called precipitate. So here NaHCO3 form PPT, and the ammonium chloride, that is NH4Cl, that remain in aqueous, means in insoluble form. It's in aqueous means soluble or solution form. Okay, so this is in the solution form, like we have this one is in the solution form. So this can be separate. This NaHCO3, that is PPT, that can be easily filtered and will easily taken out. Okay, the process by which this baking soda is prepared is called solvay process. What we call it? Solvay process. Okay, got it? Understood each and everything? Okay, just concentrate here first. Okay, no need to write in anything, right? I will help you. So don't write anything, just listen to me carefully. Write when I will ask you to write the. Okay, so till now, everyone please concentrate here. Okay, now this is sodium hydrogen carbonate that is being prepared by passing ammonical brine or a solution of salt, water, carbon dioxide, and ammonia gas. When it is mixed up together, they form NaCO3. That is baking soda. But this is baking soda And the question is being asked that what is the difference between baking soda and baking powder? Because this is being used in the baking purpose, baking industries. Okay, so what happens? What is the difference between baking soda and baking powder? So this is baking soda. This is baking soda, and when it is mixed with some edible acids, when it is mixed with some edible acids like tartaric acid. Tartaric acid. Okay. So when it is mixed with some edible acid, acid means it must contain some H plus ions. It form baking powder. Form baking powder. Okay. What does it form? It form baking powder. You understood? So what is baking? What is the difference between baking soda and baking powder? Baking soda is simple NaCO3, sodium hydrogen carbonate. And what is baking powder? When baking soda is mixed with some edible acid, it forms baking powder. Okay. And the question does not ask it what is baking. It may be asked what is baking powder, but why we are mixing? Why we are mixing? Why there is a need to mix some edible acids? Okay. So, dear students, Ridwan, look at here. Look on the screen. Don't look here. Okay. That's why I ask every student to please turn on your camera. This will help me that if the student is concentrating on. Okay. Like I can see Ashwin is concentrating. Jovita is concentrating. Okay. Okay. So if you want to score very good marks, it is must that you must turn on your camera, okay, so that I can concentrate and help you to understand better in a better way. Okay. So let's move further. Now the question is why we are adding tartaric acid or edible? Why there is a need to add a tartaric acid or edible acid to the baking soda? Okay. So you know that this is sodium hydrogen carbonate. It is a basic salt. It is a basic salt. Basic salt. Okay. And why it is basic salt? Because the parent acid of this one is NaOH and H2CO3. This is parent base, and this is parent acid. And that is, it will give you NaSCO3 plus water. Okay. So this is strong base and this is weak acid. So it will give you basic salt. Basic salt means it must have bitter taste. It must have bitter taste. Okay. Understood? It must have bitter taste. Now moving further. First of all, it has the baking soda NaCO3 has bitter taste. Okay. Next one is what is NaCO3? Actually, you see that it is sodium hydrogen carbonate. Sodium is metal, and this is hydrogen carbonate. Okay. So when sodium hydrogen carbonate is mixed with acids, okay, and when it is added to water, when we add it to water, so reaction will start because acids show their property only in water in aqueous state. So when it is, if the acid is mixed, but it is not mixed in water, it will not show any properties. Acids show their property only in aqueous state. So when this mixture of edible acid and baking soda comes in the contact with water, the reaction will start. What is that reaction? You know, this is metal hydrogen carbonate. When react with acids, it will give you salt plus carbon dioxide plus water plus carbon dioxide. And this carbon dioxide is the thing that we need, because when we put this solution or the mixture of this one in our dough, when we have this container like this, okay, and we are just having the dough here, okay, so when we add baking powder, not soda, powder to it, and water is added, so the reaction will start and the carbon dioxide will produced. This will increase the size of the dough because carbon dioxide is being trapped here. The size of the dough will increase. And this carbon dioxide means get locked in the dough. When we keep this one in the oven, due to heat, this carbon dioxide escape or leave the dough. Then what happens? The place where the carbon dioxide was trapped, the holes or the space will remain as same. And when we open it or when we take it out, we'll see that the air space is in the bread, or this means the bread fluffy. Okay. So this carbon dioxide is helping them in making the bread fluffy. This carbon dioxide is helping in making the bread fluffy. And how this carbon dioxide is produced? When baking soda react with edible acid, that is tartaric acid. The reaction starts, carbon dioxide is produced, and this carbon dioxide helping making the bread fluffy. Okay. So we can simply say that this edible acid, the tartaric acid, help in the production of carbon dioxide, which is helping in making the bread fluffy. Moreover, as you know, this is sodium hydrogen carbonate. This is baking soda, and it is basic salt. Basic salt. This has bitter taste. Bitter taste. Okay. And if we add acid to it, so it will neutralize the bitter taste, because base plus acid means neutral reaction. So it is basic to some extent. It is a salt, but it is a basic salt. So when we add acid to it, it will neutralize the bitter taste. So it will give you some salt plus carbon dioxide plus water, and this salt now don't have the bitter taste. So it help in neutralizing the bitter taste. This acid help in neutralizing the bitter taste of. So first of all, it is helping in elimination of carbon dioxide, production of carbon dioxide, that help in making the bread fluffy, and moreover, it is helping in removing the bitter taste or neutralizing the bitter taste of the one. Okay, so please note this one. Note this. Start. Note this.
Sir, baking powder formula is not needed, right?
No, baking powder does not have any formula. It is a mixture of edible acid. Baking soda has a formula. Okay, it is a mix.
Okay, sir.
But sometimes it is being asked in the examination that what is the formula of this one. So you can write that one. Okay.
Okay, sir.
Done.
So tartaric acid is a weak acid, right?
Yes, tartaric acid is edible acid, is a weak acid, and it is consumable acid that you can eat, like citric acid that is present in the citrus fruit like oranges, lemon. Okay, tartaric acid is present in the tomatoes.
And baking soda changes to baking powder only when it is weak acid, right? When it is added with weak acid.
Yes, it is added with. No, no, it's carbon dioxide can also be produced when it is added with a strong acid, but we are using this one as a as baking purpose. If we use a strong acid, then it will give you means it will give you, if a strong acid is being added, then it will give the acidic taste. Okay. And we are just neutralizing this one. And moreover, we cannot use a strong acid because a strong acid can, you know, that it can means it can change the taste of the food. Moreover, it can it is not suitable for eating. We don't add hydrochloric acid to the food. Not this just
Done, sir.
done. Everyone. This one write it fast. Amar, are you writing? Hashid?
Yes.
Writing.
Jaslin and Madhya? Madhya, are you getting?
Yes, sir.
Jaslin, are you there? Jaslin. Jaslin is not here. Jaslin, are you there? Yes, sir, done. You're replying in message. Why are you not unmuting this? Chalo, okay. Done. So note the next one.
Done, sir.
Okay, note this one. Fast. Please increase your speed. Okay, note it down fast. What is the role of edible acids? Done. Noted.
Done, sir.
Okay. Let's move on. Now you need to keep in mind that this baking soda is also used in soda fire extinguisher. Why? Because this is sodium hydrogen carbonate. There is a bottle present here in the fire extinguisher. Okay. And in this bottle, the acid is filled. Okay. The acid is filled. And this is a tip. This is a this when we push this one, this break, this bottle get break and acid mix with this one. Okay. And this produce help in the production of carbon dioxide. And this carbon dioxide produced help in the in extinguishing the fire. Okay. So you can write here that why baking soda is used as soda fire extinguisher, because this sodium hydrogen carbonate when react with H2SO4, it produce carbon dioxide. And since carbon dioxide is heavier than carbon dioxide mass is 44 and oxygen mass is 32, because carbon dioxide is heavier than oxygen. That's why it is used in soda extinguisher fire, soda acid fire extinguisher. Okay, so note it down till here. Write that only that it is used in soda acid fire extinguisher because when it reacts with acid, it produces carbon dioxide that is heavier than oxygen and help in extinguishing the fire. Done?
Yes, sir.
Shall I move further? Okay, let's move further. So if the question comes in examination like this question, for making cake, baking powder is taken. Baking powder is taken at home. If at home your mother uses baking soda instead of baking powder, okay, how will it affect the taste of the case of the cake? The cake will not become fluffy and it will be bitter in taste. Okay, not fluffy, not a fluffy, and bitter in taste and bitter in taste. Okay. Well, how can baking soda be converted into baking powder? You know,
With tartaric
Edible
acid.
acid.
by adding the tartaric acid. And what is the role of tartaric acid? You know, it helps in the production of carbon dioxide. And I hopefully that you can answer. Hopefully, you can answer these three questions. Very easily. And so let's move further. Let's study the caustic soda. Okay, caustic soda, the preparation of caustic soda. How caustic soda is prepared? Caustic soda is NaOH. It is caustic soda. Caustic soda. And when we have NaOH, sorry, NaCl. NaCl, this is common salt. Common salt. Okay. When it is added to water, or we can use it as a brine. Brine. Okay, this is called brine. Okay, or we can consider aqueous solution of common salt. We can say aqueous solution of sodium chloride. Okay, so anything can be given. Okay, either it can be NaCl plus water, it can be NaCl, or like aqueous solution, it can be brine. Okay, so when electricity is passed through it, electrolysis means electricity is passed. Then it will gives you NaOH plus chlorine gas plus hydrogen gas. You know, chlorine is hydrogen is positively charged, so it will move towards the negatively charged rod, and negatively charged rod is cathode. So it will produce at cathode. Chlorine gas will be produced at anode because it is negatively charged. And negative charge will goes towards the positively charged rod is anode. And this NaOH will be produced near cathode. Okay. So it can be produced. Okay. And now you need to keep in mind that this is caustic soda. And this process is called chloral. Don't write anything right now. Just listen to me first. This NaOH is called alkali because NaOH is soluble base. NaOH is soluble base. And soluble base means water dissolving base. Not every base can dissolve in water. What is alkali? The base that dissolve in water is called alkali. So NaOH is water soluble base. Okay, so that's why it is called alkali. This is an alkali. And this is chlorine gas. Chlorine gas. Chlorine gas. So that's why this process by which we prepare caustic soda is called chlor-alkali process. Okay, what is called chlor-alkali process? So note it down. Note this one, caustic soda. Caustic soda NaOH can be prepared by passing electricity to aqueous or concentrated solution of sodium chloride. For this one. Ashwin, why are you not writing?
So what's this prepared by passing electricity?
Passing electricity.
Passing.
Write it fast. Noted?
Done, sir.
Sir, I have one doubt.
You have not done. Write it fast.
Sir, I
Right.
have one doubt.
Yes, ask.
Sir, NaOH, why is NaOH close to cathode?
Because Na is positively charged ion, okay? And the electropositivity of Na is more than the OH negative ion. So Na will remain near the positively charged. Sorry, Na is positively charged, so it will remain near to the negatively charged what it is cathode. Okay.
Okay, sir.
Done.
Yes, sir.
Okay. Now you need to write the nature of this one also. Write the physical properties because they are important. Write it fast. The physical properties of NaOH is it is white, translucent, and the melting point of this one is 591 Kelvin. Readily soluble. What readily means? Means it does not instantly solve in water. It take time. So it is not readily soluble. Readily means deliquescent means when kept in open air, it absorbs moisture and becomes sticky. When kept in open air, it absorb moisture from air and become sticky. When it is for a long time, when it is kept in open air, it will absorb the it will react with the atmospheric carbon dioxide. When you keep this one in for a long time in open air, so it will absorb the carbon dioxide. It will react with the carbon dioxide and form sodium carbonate and water. Okay. Write down the uses also.
So what is the last point? Atmospheric CO2 and
Mhm.
it reacts with atmospheric CO2 and
And form sodium carbonate. Sodium carbonate. Done. It is used in manufacturing soap, detergent, paper, silk, preparation of bauxite.
Done, sir.
Then sir.
Okay. Let's move to the third salt.
Okay.
That is bleaching powder. And bleaching powder is actually calcium oxychloride. Okay. So you have to keep in mind bleaching powder is calcium oxychloride. Let me explain you that bleaching powder is calcium oxychloride. This is bleaching powder, and the common name for this is common. This is the common name, but the chemical name is calcium oxychloride, or it is also called calcium hypochlorite. Hypochlorite. So 1 marks question can come from this name. That is, what is the chemical name of bleaching powder? That is calcium oxychloride, calcium hypochlorite. How it is prepared? So when slag lime, dry slag lime. What is slag lime? This is calcium hydroxide. It is called slag lime. Slag lime is mixed with carbon dioxide, sorry, chlorine gas. It's mixed with chlorine gas, and it will gives you calcium oxychloride plus water. Okay, this is bleaching powder, and this has a strong smell of chlorine. Okay, bleaching powder has a strong smell of chlorine. Okay, now you need to keep in mind that slag lime and lime water has same formula. Just slag lime, they have the same formula. Same formula. But actually slag lime is paste like structure, like we have toothpaste, and lime water is a solution. It is a liquid, and it is a solution like we have sugar solution, salt solution. Okay, you understood? Large amount of water and a little bit amount of calcium hydroxide, and we have a concentrated or paste like structure of calcium hydroxide. Then it is slag lime. You understood? Understood, everybody?
So what is the difference between HNO3 and CaOH twice
HNO3?
and silicate line?
HNO3 is nitric acid. And calcium hydroxide is actually base. HNO3 is nitric acid. Okay. So let's you understood each and everything. And the process by which we prepare this one is called Hazen-Clever process. Okay. So let's you know that. How chlorine gas is produced. So this is the bleaching powder. Okay. And how bleaching powder is prepared. Then when we pass preparation, you can write it. Put it down. Put it down, please. The bleaching powder can be prepared with calcium oxychloride. Calcium hydroxide is passed with chlorine gas. And this process is called Hazen-Clever process. Not it fast. Done. Done. Noted. Why are you not replying?
Yes, sir.
Incident.
Second, sir. I'm doing the last line.
Okay, okay.
Can you go back?
Yes, yes, yes.
Done.
Done. Okay, now the uses of that what are the uses and put it down. It is a white yellowish colored powder with a strong smell of chlorine. Okay, and it will be asked in the examination that a compound X which has a strong smell of chlorine, and this means a question related to bleaching powder may be asked, but you need to remember that which compound has a strong smell of chlorine. So that is bleaching powder. Okay. So it is yellowish white powder which has a strong smell of chlorine. When it is kept in open air, just it is so many times this question is being asked that why bleaching powder should be kept in open air, in airtight container. Why do we keep this one in airtight container? In order to prevent it from reacting with atmospheric carbon dioxide. Because when it is kept in open air, it reacts with atmospheric carbon dioxide. Okay, and will form calcium carbonate. What it form? Calcium carbonate. This is calcium oxychloride. When it react with carbon dioxide, atmospheric carbon dioxide, atmospheric. Okay, so it will react what? It will form calcium carbonate, CaCO3, and this chlorine gas will be eliminated. The bleaching action is done by chlorine only. Okay, the bleaching property, the bleaching powder, the functions of chlorine, that is done by chlorine gas. Okay, if there is no chlorine, there is no bleaching powder, so no action will be done. That's why, in order to prevent it from reacting with atmospheric carbon dioxide, bleaching powder is kept in airtight container. Okay, so note it down to avoid this bleaching powder is kept in airtight container. Okay, note this. Done. Till here, noted till here.
Done, sir.
Done, sir. Done.
Done. Okay. So when is let it be let for this. The uses of bleaching powder, it is so you can use it as you have right. And it is has a strong smell of chlorine and it is a strong disinfectant which it is used for killing germs. Okay. And it employed for making the wool unshrinkable. It is a strong oxidizing agent. Okay. So notice 3 points at least. Done.
No, sir.
I had only 3 points. So we don't have time. We need to practice questions.
Done, sir.
Done, everybody? Or you can check it from your textbook. Okay. The uses of bleaching powder are very easy. So let's do the numerical problems. Right, the problems related to these questions that we're going to have examination. Okay. For example, this is a compound. Okay. So tell me, do this one. What is A and B? Note this question in your copy fast. Note this question in your copy fast. And when you're done, please let me know. Ashwin, are you there?
Yes, sir.
The compound X on electrolysis produce strong smell of base. Okay.
Done, sir.
Done? Okay. A compound X on electrolysis is an aqueous solution that provides a strong base. So what is X, Y, and Z? Tell me. X, Y, A, and B. What is X?
NaOH.
NaOH. Compound X on electrolysis in an aqueous solution produce a strong base. Check it again. Check it. What is X?
NaCl.
Yes, it is NaCl. NaCl in aqueous means in water, and it is electricity is passed through it. Electricity is passed through it. It will gives you NaOH plus chlorine gas plus hydrogen gas. Okay, this is X compound. Now reading to the next one. Produce two gases A and B. They are the two gases A and B, which will be considered A as A and B.
Cl2 and H2.
Cl2 and H2. What is A? Specifically tell me what is A? Chlorine or hydrogen?
Chlorine.
Why chlorine? You know that A and B. B is used for manufacturing bleaching powders. Which one is used for manufacturing? Chlorine is used for manufacturing. So B is chlorine. Okay. That is B, that is A, and this is common base, that is Y. Okay, so note it fast.
Done, sir.
Okay. Bleaching powder is prepared by passing chlorine gas. Okay. Done. Let's you move to the next question. Note this question in your copy. Done. Note it, everybody. Read the question 2 times. Done. So let's have a metal carbonate X1 reacting with acid gives a gas which when passed through a solution Y gives the carbonate back. So first of all, tell me which gas is produced when metal carbonate react with acid. Metal carbonates when react with acid, which gas is produced?
Hydrogen gas.
Hmm? But the metals when react with acid, they produce
Carbon dioxide.
carbon dioxide gas is produced. So let's consider this is metal carbonate. Metal carbonate. We don't know what is which metal carbonate it is. It is calcium carbonate, magnesium carbonate, sodium carbonate. We don't. Okay. That this is X. When it reacts with acid, we don't know which acid is it. It forms salt plus water plus carbon dioxide. And this is confirmed that when metal carbonate react with acid, they produce a gas, and the gas is carbon dioxide. So this is carbon dioxide gas. Okay. Produce a gas which is passed through a solution Y. And now this is a Y solution, and this carbon dioxide is passed through it. Okay. Gives the carbonate back. Means it gives this carbonate back, means X again. Gives the carbonate back, means X again. Okay. Now, just listen to me. Now you have to use your knowledge. On the other hand, a gas G is obtained at anode during electrolysis. A gas G that is obtained at anode during electrolysis of brine is passed through dry Y. So which gas is produced at anode? A gas, on the other hand, a gas G that is obtained at anode. So if I'm writing this, electrolysis of brine, NaCl plus water, electricity you pass it, electricity, it will give you NaOH plus chlorine gas plus hydrogen gas. Tell me which gas is produced at anode during the electrolysis of brine. That is gas G. Which gas is produced, hydrogen gas or chlorine gas?
Chlorine gas.
Chlorine gas is produced at anode. This is produced at cathode because it is positively charged, it goes to negatively charged. So this is gas G. So this is gas G. Now it is saying, on the other hand, a gas G that is obtained at anode during electrolysis of brine. So this is electrolysis of brine, the gas G. So Cl2 and okay, during electrolysis of brine is passed on dry Y. Is passed on dry Y. Dry. This is Y. This is the Y solution. This is Y solution. Solution. But this is dry Y. This is dry. Okay. And gives a compound Z which is used for disinfecting and killing germs. When it is passed, this gas that is obtained at anode. Okay. When this is passed to dry Y, it gives a substance that is used for killing germs. So which compound is used for killing germs?
Bleaching powder.
Bleaching powder, that is calcium oxychloride,
Cl2.
that is Z. What could be Y?
H2.
What is Y?
What, CaOH twice.
Yes, Y is calcium hydroxide, because calcium hydroxide, when a chlorine gas is passed through calcium hydroxide, it gives you Z. Okay. Now this is the solution. This is a solution. So this is solution, or whether it is the same. That is calcium hydroxide. So calcium hydroxide, when passed through carbon, when carbon dioxide is passed through calcium hydroxide, what it gives you? This is lime water. Lime water. Solution means lime water. Lime water when passed through calcium, when carbon dioxide is passed through lime water, what it will gives you? It will give you calcium carbonate, CaCO3 plus water. Give the carbonate. This is X. So this is X. This metal carbonate is calcium carbonate, CaCO3. So note it down. X is calcium carbonate. Okay, note it down. And when you're done, you can leave this meeting. Okay. Copy this question, and when you're done, you can leave this meeting.
Thank you, sir.
Sir, bye, sir.